In previous sessions, we have looked at some equations that allow us to carry out a few calculations involving compounds. We have seen how particles of a substance can be converted to moles of that substance and vice versa using Avogadro's number, which is 6.022 times 10 raised to 23. We know that 1 mole of every substance has Avogadro's number of particles. We've also worked with another equation that relates moles of a substance to mass of the substance using the molar mass of the substance, which is calculated by adding molar masses of every atom in that substance, in the chemical formula of that substance. We know that 1 mole, the mass of 1 mole of every substance equals the molar mass of that substance in units of grams. Previously, a few sessions, I think towards the beginning of the quarter, we had discussed how density of a substance relates the mass and volume of that substance. We know density is equal to mass divided by volume. And very recently in the last session, we also talked about how the subscripts in the chemical formula can be used to obtain conversion factors for moles of a substance to moles of elements in that compound or vice versa whenever you have to do those calculations. So we've seen basically all of these equations being used separately, but now we are putting them together to create this big picture. This picture, anything in this picture can be calculated starting from any other point in this picture by using those basic equations that we've seen before. Just to rewrite those equations that we've used before, we know that 1 mole of every substance contains 6.022 times 10 raised to 23. That's the Avogadro's number, uppercase N, particles. Now do remember that particles can either be atoms, molecules, or ions, or formula units, depending on the context. We've also seen before that the mass of 1 mole always equals to the molar mass of that substance in units of grams, of course grams per mole, because it's the mass of 1 mole. And we've also seen how density equals mass of a substance divided by its volume. And we've also seen equations that use subscripts in the chemical formula to figure out molar ratios between compound and elements in that compound. So let's use this big picture to do some calculations. Here's an example. Calculate the mass of oxygen in 3.35 times 10 raised to negative 3 pounds of lead 4 oxide. And once again, this is how I use the big picture. Please use it if you find it convenient. If you don't worry about it. It's all ratios. That's all what these conversions are. So in this problem, we are given pounds of lead 4 oxide. Lead 4 oxide, of course, is a compound, and from previous sessions, you probably are able to write the chemical formula of this compound, which will be PbO2 because it's lead 4. Oxygen has oxide ion has a charge of -2, so lead must have a charge of +4 because of this number right there. Okay, so PbO2, that's a compound. In other words, we know in this problem we are given the mass of compound A, which is PbO2. They're asking us to calculate the mass of oxygen in this compound. In other words, they're asking us to calculate mass of B, where B is the oxygen in PbO2. So this is our starting point, and this is our destination point. Therefore, you can use this picture as a means to figure out the path. In other words, we have to go from there to moles of A being, please remember, PbO2 in this case. Moles of A can be converted to moles of B being oxygen in PbO2 in this case, and then moles of oxygen can be converted into mass of oxygen using appropriate conversion factors. So you can use this picture to set up your problem given the information and given what you have to calculate. Okay, so let's get started. Always start with what's given and that needs to be converted. In this case, what's given is 3.35 times 10 raised to minus 3 pounds of PbO2. Please write down all the labels. PbO2 is important here because you'll be shuttling between PbO2 and O in PbO2. So you have to be very careful of your labels. Okay, now please remember that in order to go from mass of PbO2 to moles of PbO2, you need molar mass of PbO2. Molar mass is always given in units of grams per mole, but the mass given right now is pounds, so your first step has to be to convert pounds into grams. Pounds crosses out. Now, we of course need the molar mass of PbO2, which if you calculate ahead of time, comes out to be 239.20 grams per mole. In other words, 1 mole of PbO2 has a mass of 239.20 grams. So grams crosses out. We now have moles of PbO2. Moles of PbO2 can be converted into moles of oxygen in PbO2. So moles of PbO2 goes on the bottom so that it can be crossed out, converted to moles of oxygen in PbO2. Please note it is oxygen as an element, oxygen O, and not as an O2, because we're not talking about free oxygen, we are talking about oxygen content in PbO2. And so in this case, of course, we use the chemical formula to figure out this molar ratio. 1 mole of PbO2 contains 2 moles of oxygen, as you can tell from the subscript. So now at this stage, we are at moles of oxygen in PbO2. Moles of oxygen in PbO2 can then be converted into grams of oxygen in PbO2. Now once again, note it's not O2. That means 1 mole of O has a mass of 16.00 grams of O. Moles of O crosses out. We are left with, at the end, mass of oxygen, meaning grams of oxygen. Of course, 1 pound contains 453.6 grams. If you calculate this, we get 0.2032856,187 grams of oxygen. Finally, we round them to 3 significant figures based on that number, and therefore the final answer is 0.203 grams of oxygen in 3.35 times 10 raised to negative 3 pounds of PbO2. Okay, let's try this problem out. It's very similar to the one before. My suggestion will be for you to pause the recording at this stage while you attempt to set it up on your own. And in this problem, we are given a mass of carbon in glucose. That's the compound. Carbon is one of the elements that is making glucose. So in this case, we know mass of B being carbon in glucose, and they're asking us to figure out how many molecules of glucose, in other words, particle of A. So once again, our path is clear here because we have to start with mass of carbon, convert that into moles of carbon. Moles of carbon can be converted into moles of glucose that has that carbon, and then moles of glucose can be converted into molecules of glucose to contain these many milligrams of carbon. Okay, so let's set up this problem. We once again start with what's given, 6.50 times 10 raised to 4 milligrams of carbon. Milligrams of carbon has to be converted into grams because molar mass, please remember, is always in grams. 1 milligram contains 10 raised to minus 3 grams. Once you have mass of carbon in grams, grams of carbon can be converted into moles of carbon. Moles of carbon can then be converted into moles of glucose that contains those many moles of carbon. Excuse me, that's 6. And then moles of glucose can be converted into molecules of glucose, and that is what we need to calculate in the end. Putting the numbers down, and once again, please make sure you understand where these conversion factors come from. We know from the molar mass of carbon that 1 mole of carbon has a mass of 12.01 grams. We know from the chemical formula that 1 mole of C6H12O6 has 6 moles of carbon because of the subscript 6. And we also know that 1 mole of glucose contains Avogadro's number of particles. Okay, so now since we've set up the problem in order to calculate the molecules, go ahead. The calculator answer comes out to be 5.432001102 times 10 raised to 23 molecules of C6H12O6. This needs to be rounded once again to 3 significant figures based on that number, and therefore the final answer is 5.43 times 10 raised to 23 molecules of glucose. Okay, let's try the next one. Once again, please pause the recording while you set up the problem on your own first before we do anything else. Now, let's evaluate the information given to us. We know that we are talking about a compound alcohol, rubbing alcohol, whose chemical formula is C3H8O. May not be a bad idea to calculate its molar mass. The molar mass of this comes out to be 60.11 grams per mole. And it contains those many hydrogen atoms. And of course, the density of this is given as well because they're asking us to calculate the volume. So once again, evaluating what's given to us and what's being asked to calculate, that will help you figure out the path. We have the number of hydrogen atoms in that sample of rubbing alcohol, and they're asking us to calculate the volume of rubbing alcohol that will contain those many hydrogen atoms. So your path, once again, you're starting with particles or atoms of hydrogen to moles of hydrogen to moles of rubbing alcohol, to mass of rubbing alcohol, and then using the density as an equivalence factor, a conversion factor, we can then calculate the volume of rubbing alcohol. Okay, so let's use this to set up our problem. We are going to start with whatever data is given that needs to be converted. Density does not need to be converted. It is the hydrogen atoms. So we start with 7.85 times 10 raised to 24 hydrogen atoms. Please label your numbers so that you do not lose track of them. Now, hydrogen atoms can be converted into moles of hydrogen. That's the first step. Moles of hydrogen can then be converted into moles of rubbing alcohol, that is C3H8O from the chemical formula. That's your second step. Moles of rubbing alcohol can be converted into, so moles of C3H8O can be converted into grams of C3H8O. Now you have grams, but notice that the mass unit in the given density is kilograms, so not a bad idea to convert the grams into kilograms right now. So grams to kilograms of C3H8O. This will cross out. And then we can use the density as a conversion factor by putting kilograms the denominator and meter cube on the numerator. Now, our meter cube is definitely a volume unit, but the question is specifically asking us to calculate the volume in milliliters. So we are not done yet. We will need to convert meter cube into mLs. Now, how do we do that? We know that mLs can be related to centimeter cube. So our first step is to convert meter cube to centimeter cube, so that the meter cube crosses out, and then of course centimeter cube can be converted to milliliters. Okay, let's put in our numbers there. We know that 1 mole of every substance contains Avogadro's number of particles, in this case hydrogen atoms. We know that from the chemical formula, 1 mole of C3H8O contains 8 hydrogen atoms, mole of hydrogen atoms. From the molar mass of C3H8O, we know 1 mole of C3H8O has a mass of 60.11 grams. 1 kilogram of is equal to 1000 grams. From the density, we know that 800.0 kilograms of C3H8O will have a volume of 1 meter cube. That's what kilograms per meter cube means. And then we know that 1 centimeter equals 10 raised to minus 2 meters, which therefore means 1 cube centimeter cube will equal 10 raised to minus 2 cube meter cube. And then also 1 ml equals 1 centimeter cube. If you calculate this carefully, the answer that comes out to be is 122.4322017187 mLs of C3H8O. This also needs to be rounded to 3 significant figures, meaning right there gives us the final answer of 122 mLs C3H8O. Okay, let's very quickly try out this problem. As before, please pause the recording while you attempt it on your own before you continue watching the recording. Now, I would like for you guys to try this on your own, and I'm only going to write down the answers here so that you can confirm whether your answers are correct or not. If not, of course, please talk to me so I can walk you through this again. Following exactly the same procedure as we did in the previous few examples, the answer for A would be 4.213 moles of atoms. Now, when they say moles of atoms, they are talking about all the atoms. Please note that 1 mole of this compound has a total of 53 atoms. So if you add up all of them, one molecule has 53 atoms total. So 1 mole of progesterone has a total of 53 moles of atoms. Moles of atoms, not atoms. So the answer therefore comes out to be that. B has an answer of 1.005 times 10 raised to 24 carbon atoms. And the last one, 2.409 grams of hydrogen. Please confirm these answers before you move on to the next session.